SpaceX Flight 10 just broke the explosion curse. But here's what they're not telling you. While everyone celebrates the successful landing, the real moonshot depends on something never attempted: refueling giant rockets in orbit. With China targeting 2030 and their flawless track record, this untested technology could decide who wins the new space race. Today we'll reveal why orbital refueling is SpaceX's biggest gamble yet. SpaceX Flight 10 represents a watershed moment that few fully understand. After 3 consecutive test missions ended in destruction or fell short of major objectives, this flight achieved something that seemed almost impossible just months ago. Both stages of the massive Starship system returned nearly intact. But to grasp why this matters, we need to understand what actually happened up there. The Super Heavy booster, standing 230 feet tall and powered by 33 Raptor engines, executed a controlled return to a designated splashdown zone. Think of it like landing a 20-story building backwards while it's on fire. Except here's the kicker. One of those 33 engines actually shut down during ascent. And here's what few people realize. The booster still managed to hover just above the water using an alternate engine configuration before its controlled ocean landing. This isn't just impressive, it's a testament to the redundancy that makes or breaks missions. Why would SpaceX accept this risk? Because they're not just testing a rocket, they're validating a philosophy. Every Raptor engine represents millions of dollars and months of manufacturing. Losing one during flight could have been catastrophic, but the system adapted in real time. This is the difference between theoretical engineering and battle-tested hardware. Meanwhile, 400 miles downrange, the upper stage Starship was writing its own chapter of aerospace history. It successfully opened its payload bay doors. Imagine opening the trunk of your car while traveling at 17,000 miles per hour, and deployed 8 Starlink satellite mass simulators using what SpaceX calls a PIA's dispenser-style mechanism. But there's a detail most people overlook. This wasn't just a technology demonstration. It was proving that Starship can function as an orbital deployment platform, opening revenue streams that could fund the entire Mars colonization program. The engineering elegance is remarkable. They've essentially created a cosmic vending machine that can deliver satellites, space stations, or lunar landers with surgical precision. Each deployment required split-second timing, precise orbital mechanics, and flawless mechanical execution. We'll come back to this point later, but this capability alone could revolutionize the satellite industry. The re-entry sequence captured on onboard cameras showed Starship's heat shield withstanding the brutal 3,000-degree Fahrenheit temperatures as it screamed back through Earth's atmosphere. But here's where the story gets interesting. Part of the vehicle's aft skirt actually broke apart during re-entry, and one of its control flaps showed visible damage that was clearly visible on the live stream. And here's what's truly noteworthy. Neither issue affected the final landing sequence. The vehicle compensated for the damage, adjusted its flight profile, and still managed to execute a controlled ocean touchdown. This isn't luck. It's robust engineering design that anticipates failures and builds in multiple backup systems. These aren't minor achievements, and the timeline context makes them even more significant. SpaceX had originally hoped to complete these same objectives earlier in 2024. The program is now at least 6 months behind its internal timeline, which creates cascading effects throughout NASA's entire Artemis program. Industry insiders know that every month of delay in Starship development pushes back America's lunar return and gives China more time to close the gap. The flight wasn't perfect, and SpaceX doesn't pretend it was. But here's what the critics miss. Engineering at this scale means accepting that things will break, systems will fail, and the question becomes whether your design can handle those failures gracefully. Flight 10 proved that Starship's design philosophy, massive redundancy, and robust engineering can work in practice, not just in computer simulations. But this is just the beginning. What's really surprising is how this single successful test flight masks the truly unprecedented challenge that lies ahead, one that makes landing a rocket look like a warm-up exercise. This leads to a remarkable discovery. The successful Flight 10 has shifted the entire conversation in the space industry. NASA Acting Administrator Sean Duffy immediately took to social media, declaring, This paves the way for the Starship human landing system that will bring American astronauts back to the moon on Artemis 3. His confidence was unmistakable. In 2027, we will return American astronauts to the moon. We won yesterday's space race. We'll win today's space race against China. But Duffy's confidence masked an engineering challenge so complex that even NASA originally identified it as a significant weakness in SpaceX's proposal. The issue isn't landing on the moon, it's getting there in the first place. Unlike the relatively straightforward Apollo missions that launched directly to the moon with massive Saturn V rockets, Starship's lunar mission requires something that's never been attempted at this scale: orbital refueling. But the real story begins when you understand the physics involved. Starship can only reach low Earth orbit on its own fuel tanks. To travel to the moon, it needs between 6 to 20 additional Starship launches. And here's the shocking part. Nobody knows the exact number because this technique has never been tried. Even Elon Musk's estimates have ranged from single digits to potentially 20 launches per lunar mission. Think of it like this. Imagine trying to refuel a race car while both vehicles are traveling at 17,500 miles per hour, 250 miles above Earth, with fuel so cold it would instantly freeze anything it touches. Now imagine doing this 15 to 20 times in rapid succession with perfect precision, because a single failure could doom a billion-dollar mission and potentially kill astronauts. And here's what few people realize about the technical complexity. Each tanker flight must dock with the lunar-bound Starship in orbit and transfer cryogenic liquid oxygen and methane at minus 297 degrees Fahrenheit. The fuel must be kept at these extreme temperatures, or it will boil away into space. The docking mechanisms must work flawlessly in the vacuum of space. The transfer pumps must operate without any ground support systems. What happens if even one of these refueling attempts fails? The entire mission timeline collapses. There's no backup plan, no alternative route to the moon. This is why industry analysts call SpaceX's approach either revolutionary or reckless, depending on who you ask. The competitive landscape makes this even more critical. China has laid out their own lunar timeline targeting 2030, backed by their remarkably consistent track record of meeting space milestones on schedule. Here's something most people don't know. China has never missed a major space milestone they've publicly announced. Their recent successful tests of the Long March 10 rocket and Chang'e lunar lander aren't just technological demonstrations. They're strategic positioning moves in a game where second place might as well be last place. SpaceX must prove it can launch and operate multiple Starships in rapid succession at a pace that exceeds even their proven Falcon 9 rocket, which has been flying regularly for over a decade. The operational tempo required would be nothing short of historic, potentially one Starship launch every few days for weeks at a time. NASA has already amended SpaceX's contract to include an additional requirement that wasn't originally planned. The uncrewed Starship must not only land on the moon, but also successfully lift off again, demonstrating the complete round-trip capability before any humans attempt the journey. But there's something they're not telling you. This change came without additional funding, meaning SpaceX is absorbing the cost and risk of proving lunar launch capability on their own dime. And here's why this changes everything. The success or failure of orbital refueling won't just determine who reaches the moon first. It could reshape the entire multi-trillion-dollar space economy that's emerging around Earth's orbit and beyond. And this is where things get interesting. The implications extend far beyond national pride or space exploration milestones. We're witnessing the emergence of what analysts project will be a multi-trillion-dollar annual space economy, and the winner of this 21st century space race may enjoy sustained economic advantages similar to what America gained from winning the original moon race. But there's something most people don't realize about the timeline pressure that's building behind the scenes. NASA's Lori Glaze recently presented a chart of critical Starship milestones leading to Artemis 3, but that chart notably lacked any specific dates. When pressed for a timeline during a Space Studies Board meeting, NASA said they had a more detailed schedule that could be shared with the committee. Here's the revealing part. If such a document was provided, it has not been made public. This silence speaks volumes about the uncertainty surrounding orbital refueling development. The technical challenges are stacking up like a house of cards, and each one depends on the success of the previous milestone. First, SpaceX must demonstrate ship-to-ship propellant transfer, originally planned for 2025, but now clearly slipping into 2026 or beyond. Then they need to prove the rapid-fire launch cadence required for operational missions. Finally, they must show that a fully fueled Starship can be human-rated, land safely on the lunar surface, operate for a minimum of 2 hours, and successfully launch back to lunar orbit. But there's a detail most people overlook about China's strategy. Their approach is fundamentally different, and it might be smarter. Their 2030 lunar mission timeline might seem more conservative compared to NASA's 2027 target, but their space program has delivered on virtually every major milestone they've announced. Unlike SpaceX's revolutionary but unproven orbital refueling concept, China is developing more traditional but reliable launch architectures that don't depend on untested technologies. The psychological impact cannot be understated. If China lands astronauts on the moon before Artemis 3, it wouldn't necessarily be a geopolitical catastrophe, but it would represent a seismic shift in global perception of technological leadership. Why would this matter beyond national pride? Because space capabilities increasingly translate to terrestrial economic and military advantages. The nation that controls lunar resources, orbital manufacturing, and interplanetary transportation could dominate the next century of human development. Here's the remarkable paradox that keeps space industry insiders awake at night. SpaceX's Flight 10 success might actually increase pressure rather than relieve it. The company has proven they can solve complex engineering problems and recover from the spectacular failures. But orbital refueling represents a challenge unlike anything they've tackled before. It's not just about making one system work. It's about orchestrating a ballet of multiple spacecraft, precise timing and flawless execution repeated dozens of times. What's truly noteworthy is the economic ripple effects that most people never consider. The space race of the last century cemented U.S. technological leadership for more than 70 years. It fueled scientific breakthroughs, industrial dominance, and laid the foundation for America's sustained economic advantage in everything from computers to communication satellites. Today's space race isn't just about planting flags on lunar soil. It's about securing position in an economy that could define human civilization's expansion beyond Earth. And here's something that will surprise you. Even if SpaceX succeeds with orbital refueling, they'll need to prove they can do it reliably, repeatedly, and safely enough to bet human lives on the process. NASA's safety requirements for human spaceflight are exponentially more stringent than cargo missions. Every system must have backup systems, and those backup systems need backup systems. As one industry analyst recently noted, we may be witnessing either the greatest engineering triumph of the 21st century or the most spectacular overreach in aerospace history. The difference between those outcomes lies entirely in whether SpaceX can master the art of orbital refueling, something that remains, quite literally, never done. The clock is ticking, China's steady progress continues, and the future of American space leadership hangs in the balance of a technology that exists only in computer simulations and the ambitious dreams of engineers who believe they can refuel rockets in the cosmic void. The next 2 years will determine whether SpaceX's gamble pays off or whether America watches from Earth as another nation plants its flag on the lunar surface first. This is exactly why SpaceX's Flight 10 success is both a triumph and a warning shot. We opened asking whether orbital refueling could really work. And now we know the answer isn't just technical, it's existential for America's space leadership. What this means is we're watching two fundamentally different approaches to the moon race. SpaceX is betting everything on revolutionary technology that's never been proven, while China methodically advances with reliable, tested systems. The winner gets to define the next century of human expansion beyond Earth. And this is just the beginning. The next 18 months will determine everything. SpaceX must demonstrate ship-to-ship refueling, prove rapid launch cadence, and show they can do it safely enough to bet human lives on the process. Meanwhile, China continues their steady march toward 2030, hitting every milestone they announce. Here's what I want to know. Do you think SpaceX's high-risk, high-reward approach will pay off? Or is China's methodical strategy the smarter play? The stakes couldn't be higher. This is Space Hub, where we break down the engineering and strategy behind humanity's greatest technological challenges. The space race is accelerating faster than ever, and the next chapter is being written right now.